This week on the Computer Chronicles, computer technology at the Olympics. If you ever wondered how those TV commentators knew so much about the athletes and the events, we'll show you the software systems that fed them the data. The network at the Olympics was one of the most secure systems ever built. We'll show you how they did it. The network backbone in Utah was run on Unix. We'll show you the massive installation of Sun servers and data storage units. You think putting your network together was rough. How would you like to build one on the side of a mountain in sub-freezing temperatures? We'll tell you how they did it. And the paperless office, not at the Olympics. 50 million pages were printed in 17 days. We'll show you how Xerox pulled it off. Computer technology at the Olympics, coming up next on this edition of the Computer Chronicles. Computer Chronicles is brought to you by the Oracle Small Business Suite. One completely integrated application that helps make it easier to run your business, including accounting, sales and service, your web presence, and more. Additional funding is provided by PC to PC, the online migration service from PC First, moving files, applications, and preferences from your old computer to your new one. Hi, and welcome to this special edition of the Computer Chronicles. We're in Salt Lake City, Utah. That's the Mormon temple there behind me. This, of course, was the site of the Winter Olympic Games. I'm sure many of you watch the games on television. What we're going to do this week is take you behind the scenes and show you the computer technology and the IT infrastructure at the Olympics that made it all possible. The overall integrator for IT systems here at the Winter Olympics was a company called Schlumberger Sema, previously known primarily for supplying technology to oil drilling companies, but now involved in the world's largest and most unique sports technology contract.
The Olympics is a huge system. I think perhaps people don't understand just how large the system is we install here. When we have the system up and running during games time, we have approximately 3,500 PCs, 150 Unix servers, 225 NT servers, 1,000 printers, 750 networking devices, and this is all joined together by a large local area network and lots of local area networks.
Well, it's unique for two reasons. One is because this contract is the greater IT sport contract in the world. That is a challenge itself. But in addition, it's because the technology is really complex, especially because it's necessary to mix a lot of different services to a people who expect big things during the Olympics, that you cannot have any failure. That is the most important. There's not second opportunities. This is the big challenge.
There were some 2,500 athletes here at the Winter Olympic Games, but there were even more techies, about 3,000 of them, working long days and nights to make sure that the computer and network systems at the Olympics were glitch-free. And while the Olympics assignment was unique, it wasn't totally different from other mission-critical applications.
The technology is the same. Client-server, the way you set things up, databases, queries, multiple sites, resilience, redundancy. It's all the same. So from a techie's viewpoint, what we're doing here is no different to what we do outside, and it's the same with our banking systems and telecommunication systems. It's a large system. The challenge we have here is the dates don't slip. 8th of February will come and we will be ready, the athletes will arrive, the opening ceremony will happen, and there's no excuses. You know, as we could like to say, this is a one-off shot, and we'll be there and we'll be ready.
You might ask, why did Schlumberger Sema have to reinvent the wheel and create a totally new IT system in Utah? Wasn't the same kind of software used at the last Winter Olympic Games in Nagano, Japan?
Well, in Nagano, we have had the information coming from Nagano. The IOC provided that information. In fact, the systems here are absolutely, except the part we provide in Nagano, basically accreditations. It was our system there. Here the systems are absolutely new. I believe that to reuse the experience in Nagano was difficult in part for the language. All the documents were written in Japanese and so on. It was not easy. I believe if it was in English, it was very much easier to reuse the experience.
Besides the language difference, there was one other small point. IBM owned most of the software that was used in Nagano, and they didn't have the contract for the Utah games. For Schlumberger Sema, the IT job here in Utah was to build a massively redundant network in the middle of snow-covered, ice-frozen mountains, guarantee its security, and provide sub-second information throughout the network.
That's the biggest challenge we have. Once that skier or that sledder comes down the hill, people want to know the results immediately. They don't want to have a delay. They want to know first, second, third. There's a huge stress to get that information to the commentators immediately so the commentators can announce, because you don't want to have the crowd reacting to a score before the commentator finds out what the result is. You want them all to be synchronized, and you're talking sometimes half a second. And
we have to be really careful about how we install all the equipment, the temperature sensitivity of all our equipment. And as we were saying, a lot of our cables run on the outside. They run on poles underground, and we have to make sure that they don't get in the way of snow plows or snow cats or even ice storms. And to help us overcome all these issues which may happen, we tend to do a lot of redundancy. We'd always have two shots in to a venue. We have twin paths and on different ways in, so if something was to go down, we have an alternative route.
There were three main application suites here at the Olympics, developed by Schlumberger Sema. One was the games management system.
This is a suite of applications, 9 of them, which support behind the games systems. We do accreditation, accommodation, medical, protocol, and things like this. No one ever sees it, but without these applications running, the games wouldn't happen. And when the opportunity came in '98 to bid for this contract, because IBM and the IOC decided not to continue their relationship, Schlumberger Sema bid against companies like EDS for the opportunity to take part in this wonderful opportunity for sporting events.
The second application suite was called Info 2002, a kiosk-based system that provided information about the games, the events, and the athletes to all officially accredited people at the Olympic venues, including athletes, judges, Olympic Committee officials, and journalists. The third application suite was called CIS, the Commentator Information System, which provided virtually instantaneous results to the television commentators who needed to see data in sync with what they were seeing live on their TV monitors. So the bottom line for software developers here was speed.
In today's world of IT technology, everyone demands instant IT communications in a flawless mode, and that comes at an expense, and the expense is integration test facilities like we're sitting here. It means our software developers have to look at applications. Sometimes we have to, for speed, we have to give up something else. And for our commentator information system, we call this sub-second response time. From the time the athlete finishes at the finish line in front of the broadcaster, all the new information has to be recompiled on his screen in the format he wants within less than a second.
One of the challenges of developing the software systems for the Olympics was that each sport had its own rules and its own application requirements.
For example, in alpine skiing, the downhill, we have skiers that get lapped. How do the result systems handle that? How do we present the output from something like that? In speed skating, we have disqualifications and other anomalies.
Each element of software has its own challenges. For instance, alpine skiing is very fast downhill, flash to bang in sort of less than a minute, and that has one unique challenges of timing, precise timing. Then you move over to ice hockey and curling, and they're driven by statistics. Ice hockey is fairly fast, but curling is not very fast, but you're collecting data all the time. So there's different challenges of the way you collect the data.
And to make it even more complicated, software developed to run World Cup events can't be used at the Olympics because the rules are different.
We have different subcontractors for each sport. What the organising committee chose to do here is that they've gone to all the federation preferred software suppliers who support the federations during the World Cups and outside of the Olympics, and we've used these federation preferred suppliers to give us our software for the Olympic Games. Now, the rules for the Olympics is different to the rules for the World Cup, so we've had to do some modifications and changes, but the basics of the software is still there.
Building this computer network would have been a big enough challenge under normal circumstances, but the IT people here had to totally regroup after September 11th.
some areas we stopped and we went back for looking for another solution. One of them is wireless. It's a very clear example. Yes, after the 11 we have analyzed the situation again. We have, in some cases, we have re-secured some areas. In another areas we have canceled the process, and in others we have let the process as it was because it was okay.
Partly because of September 11th, security, redundancy, and risk aversion were major drivers behind the design of the IT systems here.
Schlumberger Sema as an integrator wants to choose the conservative way forward. That doesn't mean to say the old-fashioned way forward, but tried and proven technology. It's like we use client-server technology, we use Unix, we use some Windows environments. What we want is systems that are stable and proven.
We are continually fine-tuning the software. We are not at this point in the game making any core changes to the system. We are very risk adverse. Everything we do, we're trying to avoid risk because we can't afford to have any kind of a failure.
The basic IT task here was to create a massive database, secure it, yet make it available instantly to millions of users at the same time. And all this to operate 24/7 for 17 straight days with no failures.
We have multiple layers of redundancies with our critical systems. We have not only hot A and B standby systems for automatic failover, we have what we call C systems, or entirely separate systems based on separate architecture in case both the primary and the secondary fail.
The thing that's unique about the Olympics, and I kind of go back to some of my military background, there's a drop dead when NBC and the television powers say that jumper has to hit this mark at this time, you have to deliver the product. There's no slippage, you have to be able to perform, and there's no second chances. You get it right the first time, there's no second opportunity. So that's the exciting part about it. We have to do it and deliver it on a particular schedule to a certain standard.
One of the challenges for the IT people here at the Olympics was the constant upgrades, debugs, and changes to the system based on early testing and user feedback. And as any programmer knows, when you make a change in one part of a program, you never know for sure what will happen in other parts of the program.
I guess one of the challenges is the fact that the systems are constantly changing. They're always doing little tweaks and trying to better the systems. So one of the challenges there is making sure everything's on the same level and that the changes they're making to better the systems are actually bettering the systems. There's no side effects.
What I like to tell people is we test, and retest, and when we don't think we've done enough testing, we do a bit more testing.
The reason they needed to test the software so much was because it not only had to work on its own, but it had to be integrated with a host of other software applications.
The challenge with large systems is, especially with large integrated systems, that there are so many interfaces, so many protocols, and if that little bit of code isn't right and it doesn't interface with that little bit of code, you'll get all sorts of things happening within the system, especially downstream applications. We take delivery of that application, we test that application to make sure it is what they say it is, we check the documentation, the configuration, and then when we're happy with the standalone application, we then put it into our test lab for what we call end-to-end integration. And as you've seen here, we have many systems we have to integrate. And from a flow process, it starts off with SEICO, timing and scoring. It flows into on-venue results, flows into our central database, and then from our central database, it flows out to our info system, to our feeds. So there's a lot to do and a lot to bring together.
While the athletes here at the Winter Olympics spend a year or two in training getting ready for the big event, that may be nothing compared to the amount of preparation the IT professionals go through. For many of the computer techies here, they've spent the last 3 years or more getting ready for this Olympics, making sure that the information systems perform as well as the athletes.
Planning for the Olympics computer system started way back in 1999. Schlumberger Sema, a European-based company, got the contract for the Utah Olympics, as well as the upcoming Olympics in Greece, Italy, and China, replacing IBM as the principal technology integrator. Schlumberger Sema had been a software subcontractor for the Olympics, starting back in 1992 at the Summer Games in Barcelona. The team working on the Olympics IT system was international, with people from all parts of the world.
We have people from over 23 different countries here. It's very exciting. We have a lot of different cultures, a lot of diverse backgrounds. One thing that we've been able to do for this project is to go throughout the world and pick the very best people to make this project a success.
During the Olympics, this was the IT Mission Control Center, actually called the ITC, the Information Technology Center. Here, engineers and technicians kept track of all the computer systems, ran a trouble desk and security operation, and managed the massive network and sub-networks that supported the IT system in Utah. One of the major challenges for the engineers at Schlumberger SEMA was to make absolutely sure their network was bulletproof and safe from hackers.
And we have a large team of security experts and analysts here in this building, and the team have been here for many, many months, and they look at all the ways we can protect our data, not only from an internal source but from an external source, because not only do we have to protect ourselves from external hackers, we have to protect ourselves from internal malicious intent. And if you look at the various IT papers, you can see on a number of occasions large corporations losing data, not from the outside, but from a disgruntled employee on the inside. So we look at both sides very seriously.
We have taken some steps to take ourselves off of the internet so that we have very limited internet access. We don't have much presence into the cloud, so people can't get to us, and those are some of the main steps. Even the people here don't have dial-up access into our own network. It's pretty much a closed system right now to the greatest extent we could. Obviously, some of the federations have requirements to be able to get in, but those accesses have been severely limited for the period of the games.
In our last technical rehearsal just before Christmas, two of the guys from our company who had nothing to do with this project were told by the company to basically hack in the way they could. And they had a good few attempts. They found a few holes, but they couldn't get into our games network, which we're very proud of.
The network backbone for the Winter Olympic Games was provided by Sun Microsystems. Some 200 Unix servers and data storage boxes were used in building the network used in Utah. Sun is used to dealing with the reliability demands of its corporate customers, and providing the network infrastructure for the Winter Olympics was no different.
We live in a real-time culture, and this is the ultimate real-time event. The spectators want to know real-time who's competing against who are in the top 3, top 5, top 10.
But perhaps more important than having to provide live event information in real time was the need to have an information system which was not 99.99% reliable, but 100% reliable.
What makes this so complicated is that information has to be duplicated and sent to many different sources. There is scoreboards, TV graphics, intranet, internet, web-based feeds. That information cannot be lost under no circumstances because the competition can never be run again. We could never apologize to a snowboard competitor and say, "We're sorry, we just lost your score. Could you do that run again?" And it might be the best of their life.
It's one thing to build the network infrastructure so that it is theoretically reliable. It's another job to monitor the network and ensure that it is in fact reliable. The company with that important job was probably one you've never heard of, Icono.
These screens are actually providing us different elements or different pieces of information that we could use to track the network. For example, up here we can see the utilization on each one of the segments that are out there where traffic's going over, just to see if there's any kind of harm, there's any kind of excess traffic where the network would appear slow. We can actually deal with that and reroute traffic. In addition, down bottom here, you see another screen which actually tells us, is the device present or not? Did it actually lose power or lose all connectivity? Are there no paths to that particular device? We could actually track this and again immediately respond to it.
With the huge demand for high-speed network traffic at the Olympics, many venues had as many as 8 separate T1 lines coming in, but that alone still didn't ensure 100% availability.
We're actually able to monitor each and every individual T1 line. Many other tools that we have aren't able to do that come straight out of the box, that are just your custom developed applications, because we're using multi-link. And when one T1 line goes down, granted we lose a portion of our bandwidth, but everything appears to be operational, and your typical monitoring tools are not able to censor it. So we've actually custom built an application that when a single line goes down, even though competition is on, even though the data is still moving, we're actually able to see it as the square there changes to a different color, and we're able to respond to it. Then we can make the decision, do we repair it now, or do we wait until after competition is over, or do we actually move the bandwidth, the path, you might say, that the data is moving from one multi-link bundle over to another one. We have these various options we can do on the fly or wait until later on.
One of the challenges of building a reliable network here was the mere physical task of putting network cables on a snow-covered ski slope.
Think about a ski slope. It's snowing, but it's time to install this network. So yes, we've had engineers out there with equipment in hand running through 1.5 feet of powder to get from one location to another, and they'll wrap the equipment in plastic to keep it protected and dry from the elements. And when you get to the other facility, it might be a trailer or even a tent on top of 3 stories of scaffolding. So they actually have to run up these ice-covered stairs to get to the top. Go inside this tent, and over in the corner is a table where you actually install this switch or whatever the network device is, and you're hooking up your cables. And meanwhile, there could be some wind blowing through this tent, so you're very concerned about snow getting on the inside of the ports and actually shorting out equipment. It's there's some high-risk components to this whole thing that's very unusual. This is definitely not a clean room environment for building a network such as we ideally want to.
Another challenge for the installers was having to manipulate fiber cables in sub-freezing temperatures.
They'll string it temporarily to a certain location, such as, and coil it up. Imagine coiling up fiber and hanging it up high in some tree alongside a ski resort. And then at the right time, when they have access to the facilities, they actually have to climb the tree with a blow dryer, warm up the fiber so that it's at the right temperature, and they can roll it out the rest of the way without breaking it because it's frozen. It's kind of interesting, and here we are relying on this to run a network that has an audience of well over 3 billion people watching. And it can't fail.
While handling the electronics at the Winter Olympics was a challenge, sooner or later people also wanted to see the results on paper. Xerox was the official print vendor for the Olympics, and it provided some 3,000 printers that were distributed throughout the various Olympic venues. There were the regular office printers that you and I would recognize, but there were also high-end publishing systems, fax machines, copiers, and plotters. During the 17 days of the Olympics, more than 50 million pages were printed on the Xerox printers, including 28,000 booklets summarizing the results for each of the 15 Winter Olympic sports. To support just the printing operation in Utah, Xerox provided more than 100 engineers and service techs, since, as we all know, printers and copiers tend to break down just when you need them the most. Now that the games are over, Xerox is converting all its hard copy results into more than 7,000 CD-ROMs as a permanent electronic record of these winter games. One unusual application of technology at the Olympics was the use of 2 special websites created by Monster.com, the only .com sponsor at the Winter Olympics.
When you look at an Olympic sponsorship, first you look at the opportunity, what the rings represent, and putting the Monster brand with those Olympic rings is huge credibility. I think the natural relationship between Monster and the Olympics is way beyond that kind of superficial branding, though. I think there's some possibilities that Monster can actually integrate at all different levels, first from the volunteers, from the professionals that are actually working at the Olympics. You look at the athletes and the fact that they're already at the top of their career. What are they going to do after they get done with the games, and how can Monster kind of embrace their challenge and help them get through the chasm in their career?
Among the 80,000 some people helping to run the Winter Olympics were 25,000 volunteers. Many of them were recruited on the special Team 2002 website run by Monster.com. Monster also put up a special jobs section on their site called Team USA Net for retiring Olympic athletes who are looking for jobs.
When the Olympic opportunity came our way, it was a real natural for Monster because there's a real natural correlation between real athletes who compete in the Olympics, and then after their Olympic career is over, they'll need jobs. And as opposed to a lot of the other blue chip properties that you could sponsor, like professional basketball or professional football, where the athletes, when their careers are over, don't necessarily need the uses of a company like Monster.com to transition into the work world.
Part of what Monster has done is create an online mentoring program in which former Olympic athletes assist current Olympians as they deal with the transition from medal winner to job holder.
Athletes really have to spend a lot of time at their sports, and people don't realize that to be a world caliber athlete, it's almost like a job. You have to dedicate 100% of your time to it. And they need somebody who's outside the sport who can look back at their career with 20/20 vision and give them some perspective on what is in store for their future.
That's it for part one of our special series on computers at the Olympics. For the Computer Chronicles, I'm Stewart Cheifet at the Winter Olympics in Utah. Computer Chronicles is brought to you by the Oracle Small Business Suite, one completely integrated application that helps make it easier to run your business, including accounting, sales and service, your web presence, and more. Additional funding is provided by PC to PC, the online migration service from PC First, moving files, applications, and preferences from your old computer to your new one. Next week on the Computer Chronicles, part 2 of our special series on computer technology at the Olympics. What would you do if 7,000 PCs showed up at your office and you had to configure them all for hundreds of different uses? We'll show you how it was done. Did you follow some of the Olympic results on the web? We'll show you the huge information systems that fed the internet. When your network has to be 100% reliable, you need lots of redundancy. We'll show you how they bulletproof the IT systems at the Olympics. And did you watch the hockey games? We'll show you the complex software systems that were used to document every single moment of each game. And computers also help the athletes go faster. We'll show you how Nike used technology to help the U.S. speed skating team. Part 2 of our series on computers at the Olympics, coming up next week on the Computer Chronicles.